Now more exercises on the limit of trigonometric functions. The theorem, we have limit as x tends to 0 of sine x over x is equal to 1. And for the corollaries, we have limit as x tends to 0 of tan x over x is equal to 1. And if the angle has different coefficients up and down, so limit as x tends to 0 of sine ax over bx is equal to a over b, and limit as x tends to 0 of tan ax over bx is equal to a over b, and x is in radians. Finally, don't forget limit of cosine x as x tends to 0 by direct substitution. This is equal to cosine 0, which is equal to 1. Now, exercise number 1. Limit as x tends to 0 of x cosine 3x over tan 2x. Whenever you have cosine, you do direct substitution. Cosine 0 is 1. So cosine 0 is 1. Now, we're going to divide up and down by x. So this is equal to limit as x tends to 0 of x over x, they cancel each other. So up we have cosine 3x, and down it's tan 2x over x. By direct substitution for the numerator, we get cosine of 0, which is 1. So this is equal to 1, and down it's limit as x tends to 0 of tan 2x over x. By the corollary, this is equal to a over b, or coefficient of x up over coefficient of x down. So this is equal to 2. So the answer is 1 over 2. Now number 2. Limit as x tends to 0 of 2 sine x minus x cosine x over sine x plus x cosine x. Now let's divide up and down by x. So let's divide each term up and down by x. So this is equal to limit as x tends to 0 of, we have 2 sine x over x minus, now the x is cancelled, it's cosine x, and here it's sine x over x plus x is cancelled, this and this, they cancel each other. Now it's cosine x. Limit as x tends to 0 of 2 sine x over x. By the theorem, this is equal to 1. And down sine x over x, by the theorem, it's also 1. What about cosine x? By direct substitution, limit as x tends to 0, cosine 0 is 1. So this is equal to 2 times 1. Sine x over x is 1, and minus cosine 0 by direct substitution is 1 over sine x over x to be 1 by the theorem, plus, and plus cosine x by direct substitution gives 1, cosine 0 is 1. So this is equal to 2 times 1 to be 2 minus 1 to be 1 over 1 and 1 to be 2, so 1 over 2. Number 3. Limit as x tends to 0 of sine 3 over 5 fourth root of x over fourth root of x. This is equal to limit as x tends to 0 of sine a x to the power n over x to the power n. So this is also equal to a. Limit as x tends to 0 of sine, if it's fourth root of x up and fourth root of x down, so this will be equal to a, coefficient of the angle. So this is equal to 3 over 5. Number 4, limit as x tends to 0 of sine 5x squared over 7x squared. If x is squared up and down, so this is equal to a over b. So this is simply equal to 5 over 7. We need to differentiate between two things. Limit as x tends to 0 of sine ax squared over x squared. If the x is squared up and down, so the theorem and the corollaries are still applicable, and this is equal to a. But if the sine is squared and down the x is also squared, So the whole thing will be squared, and this is equal to a squared. Number 5, limit as x tends to 0 of sine squared 5x over 2x squared. In this example, the sine is squared, not the angle. The sine is squared, so this means that the whole thing, the whole function is squared. And down we have 2 and we have x squared. Now we have limit as x tends to 0 of, we have 2 down here, so you can just write it as 1 over 2 of sine 5x over x all squared. Limit as x tends to 0 of sine 5x over x is equal to 5, or a. So this is equal to 1 over 2 times 5. Now this is squared, so just square the 5. So this is equal to 25 over 2. Finally, number 6, the tan is raised to the power 3 and down the angle is raised to the power 3. Now we're going to do the same thing. So this is equal to limit as x tends to 0 of, let's put the 1 over 4 outside. So tan 2x over x, the whole thing is raised to the power 3. So this is equal to 1 over 4, and by the corollary, tan of ax over x is equal to a. So tan of ax over bx is equal to a over b. b is 1, so it's equal to a. So this is times tan to limit as x tends to 0 of tan 2x over x is 2. Now this is raised to the whole thing is raised to the power 3, so to the power 3, so this is equal to 8 over 4 to be 2.